units. Okay, so it is a weight, but it is it is the mass or the weight of all of the elements naturally occurring isotopes. However, it's a weighted average. So first of all, I want to give you an example of isotopes. So first of all, hydrogen has 3 isotopes. So you have hydrogen 1, you have hydrogen 2. Oops, let me start over here. Let's try this again. Hydrogen 1, you have hydrogen 2, and you have hydrogen 3. Protium, deuterium, and tritium. So this number right here is the average atomic weight for hydrogen. So what happens is we take the weighted average of each of these isotopes to find this number right here. So let me explain to you first what a weighted average looks like. Okay, so I want to look to like your school. So if your teacher weights their grades, and let's say, for instance, tests or exams are weighted 75%, and let's say all other activities are weighted 25%. So that means tests and quizzes, okay, are going to make up the bulk of your grade because it's weighted 75%. So, quick example here. So let's say we have exam 1 and you receive 75% on it out of 100. So let's say you have exam 2 and you receive 65% out of 100. And exam 3, you received 55% out of 100. Let's say you had some activities in class, and you have activity 1, and let's say you received a 99% on it. Activity 2, and you received a 90%. And activity 3, I think I want to put that someplace else. And activity 3, put it right here. Activity 3, you received 95% of that. So if all of this made up your total grade, okay, if I added all of this together, and the total points would be, okay, for all of this, would be 479 points. But exams and activities are weighted differently. So we place more importance on your exams in this scenario versus the activities. So each exam is weighted 75%. So I would have to multiply each exam by 75% and each activity by 25% to get your actual total points. And activity 95 times 0.25. Also, for this, you are definitely getting a calculator and a periodic table. So I would take 75 times 0.75, and I would receive 56.25. 65 times 0.75 is 48.75, and 55 times 0.75 is equal to 41.25. Our activities, 99 times 0.25 is equal to 24.75. 90 times 0.25 is equal to 22.5. And last one over here, 95 times 0.25 is equal to 23.75. So each of these total point grades has to be multiplied by what it's weighted. Again, exams are worth or weighted more, or more importance is placed on their scores than the activities. So if I was to add them all together, 56.25 plus 48.75 plus 41.25 plus 24.75 plus 22.5 plus 23.75, I'm going to end up with, as long as I calculated it correctly, total 216.75. So if I take 216.75 and divide it by all the points, it is worth 479. My percentage, I would have a 45% in the class. So I have a pretty low percent, even though I've got 99, 90, and 95 on 3 of the 6 assignments. Okay. Those 3 assignments are weighted so low that they don't make a big impact on the overall grade. So our exams are weighted 75%. So they place, or they make a bigger impact on the overall grade. So you're probably wondering where I'm going with this, but this is exactly how a weighted average, right here, the average atomic weight, that's exactly the exact same example. So whichever isotope has the largest percent abundance, the weight of that isotope has a bigger impact on the overall atomic weight that is on the periodic table. So let me give you an example here. Okay, let's look at carbon. Carbon has 3 isotopes. So we have carbon 12, we have carbon 13, and we have carbon 14. So each of these are carbon. Of course, carbon 12 is going to have 6 neutrons. Carbon 13 is going to have 7 neutrons, and carbon 18 will have 8 neutrons. So that means each of them has got a different mass. So carbon 12 has a mass of 12.000. Carbon 13 has a mass, okay, in AMUs, atomic mass units, not grams, of 13.00385. Carbon 14 back and forth, but I do tend to refer to it as average atomic weight. So by definition, the average atomic weight is a weighted average, okay, of all of the masses of the naturally occurring isotopes of an element expressed in atomic mass. Okay, and carbon 14 has a mass of 14.00324. Percent abundance is basically how often you find that isotope in the atmosphere. So the larger percent abundance you have, then the more often that isotope of that element is going to be found in compounds, in molecules, in the atmosphere, so on and so forth. So carbon 12 has a percent abundance of 98.93. Carbon 13 has a percent abundance of 1.07. And carbon 14 is so rarely found, it doesn't even have a percent abundance. So what happens is we do almost exactly what I did, calculating the overall grade with a weighted system. Same thing here. See how this is such a large percent abundance? So for carbon 12, carbon 13 has a very small percent abundance. So the mass of carbon 12 has a bigger impact, okay, on the atomic weight that goes on the periodic table. So we can literally do the exact same thing that we did. And I'm going to change this to decimal form, 0.9893, 0.0107. I don't have to do anything for carbon 14 because we don't have a percent dependence. So 12 times 0.9893 is going to give us, and come down here, 11.8716 and 13.00385 times 0.0107 is going to give us 0.13914. I'm just going to add those together. And that will give us an atomic weight of 12.011, which is actually found on the periodic table. So this average atomic weight is the weighted average of all of the elements naturally occurring isotopes. Okay, the isotope that has the biggest percent abundance is going to play the biggest part or have the biggest impact on the weight that goes on the periodic table. Okay, so let's look at how we actually calculate this. So you do need a calculator and you have to have a periodic table. You also will be given a lot of information. So just like I had done before, you have to have the percent abundance of each isotope, but it's going to be in decimal form. So I had 98.93%. So I just moved my decimal over 2 to the left, and that puts it in decimal form. Or 1.07, I'd move it over 1, 2 to give me 0.0107. So your percent abundance has to be put into decimal form before you do the calculation. You need to know the mass of each isotope of the element in atomic mass units. That these will be given to you. What you'll have to do is you'll have to change the percent into decimal form and then do some calculations. So just like I did before, you take the mass of isotope 1 and you multiply it by the percent abundance in decimal form. Mass of isotope 2, multiply it by its percent abundance in decimal form. If you have 3 isotopes, or if you do have 3 isotopes, you take the mass of isotope 3, multiply it percent abundance, and you end up adding them all together. So let's do 2 examples here. So here's the first one. Calculate the average atomic mass or weight, same thing. A certain element is a soft silvery white metal that has 2 common isotopes. The first isotope has a mass of 85.0 AMUs. So I like to, first of all, you are required to show your work. I like to write all my information down. Has a mass of 85 AMUs. The second isotope has a mass of 87 AMUs. If the abundance of the first isotope is 72.2, again, I got to move that over to put it in decimal form, 0.722. And the abundance of the second isotope is